In this lesson, we want to review solving rational equations. So a rational equation is nothing more than just an equation with rational expressions involved. So something like x minus 5 over 2x squared is equal to 1 over 4x plus 1 over x squared. So earlier in our course, we talked about solving linear equations in one variable with fractions involved. In that lesson, we saw that we could clear an equation of fractions by multiplying both sides of the equation by the LCD, the least common denominator, of all fractions involved. Well, it's basically going to be the same process here. If I want to solve this equation, I would first find the LCD of all the rational expressions involved, and then I would just multiply both sides of the equation by the LCD, and I would clear all the denominators. But there's one thing you have to watch out for. When we multiply both sides of an equation by a variable or a variable expression, we will sometimes get extraneous solutions. Okay, so we talked about these in the last section when we're solving radical equations. Extraneous solutions are solutions that work in the new equation that you form, but they don't work in the original that you were trying to solve. So specifically, when you're talking about a rational equation, you want to guard against division by 0 because in a lot of cases you have variables in your denominator. So let's go ahead and try to solve this first guy here. We have x minus 5 over 2x squared is equal to 1 over 4x and then plus 1 over x squared. First and foremost, what's my LCD? We'll have a denominator here of 2x squared, a denominator here of 4x, and a denominator here of x squared. So for my LCD, the number part is what? You've got a 2 which doesn't factor and a 4 which is 2 times 2. So the number part is a 4. Then for the variable part, I've got an x squared, an x, and an x squared. So it's going to be x squared. So now that I have my LCD of 4x squared, I'm just going to multiply both sides of the equation by the 4x squared. So let's set this up. We would have 4x squared being multiplied by x minus 5 over 2x squared. And this is equal to, I'm going to go ahead and multiply the 4x squared by each part here. So we'll have 4x squared times, we have 1 over 4x. Got to make that a little better. Then plus, I have my 4x squared times my 1 over x squared. Okay, so let's go through and multiply each. Let me kind of scroll down and get some room going. We'll come back up to this in a minute. So on the left, the 4 would cancel with the 2 and give me a 2. And then x squared over x squared is 1. So essentially you have 2 times the quantity x minus 5. So you've got to make sure that you multiply the 2 by each term here. Don't just put 2x minus 5. That's wrong and it's a common mistake. So you want to say this is 2 times the quantity x minus 5. Again, wrap x minus 5 inside of parentheses. Then this is equal to, this 4 would cancel with this 4 here. And then x squared over x, the x cancels, and I'll take one of these away. So I basically have x to the first power times 1, which is x. Then plus, I can cancel this x squared with this x squared. I basically have 4 times 1, or just 4. Okay, very easy equation to solve now. 2 times x is 2x. Then minus 2 times 5 is 10. And this equals x plus 4. Let's go ahead and continue now. So if I add 10 to both sides of the equation, and I subtract x away from each side of the equation, what am I going to have? This would cancel, and this would cancel. So 2x minus x is just x, and this is equal to 4 plus 10 is 14. So my proposed solution here is x equals 14. And again, the reason I say proposed solution is that we might get extraneous solutions when we multiply both sides by, again, either a variable or a variable expression. So we need to check. So let's copy this. We'll go back up to the top. So we want to check if x is equal to 14. So I've got to plug in a 14 everywhere there's an x. So that's going to be here and here, here, and also here. Okay, so in the numerator on the left, 14 minus 5 is 9. And this is over 2 times, what is 14 squared? Well, that's going to be 196. If I just do that multiplication, 2 times 196 is 392. So this is 9 over 392, and that is not going to simplify. Then next, I have 1 over 4 times 14. 4 times 14 is 56. Then plus, well, I've got 1 over 14 squared, which we know is 196. Okay, so do we have the same value on the left and the right? Well, let's go ahead and combine these fractions here on the right and see what we get. We would think about getting a common denominator. I know 56 is 8 times 7, right? 8 is 2 cubed, then times 7. We know that 196 was built from 14 times 14, right? 14 is 7 times 2. So I can say 196 is what? It's 7 squared times 2 squared. And let me kind of reverse that order. So let me put 2 squared first times 7 squared. So my LCD is going to be 2 cubed, which is 8, times 7 squared, which is 49. If I multiply 8 by 49, I do get 392. So I know my LCD is 392. So the LCD is 392. Okay, so what do I need to multiply 1 over 56 by in order to get a denominator here of 392? Well, 392 divided by 56 is 7. So I'd multiply this by 7 over 7, and I would end up with 7 over 392. So let's erase that and just put 7 over 392. Then for this guy right here, I'd need to multiply it by 2 over 2. So by 2 over 2, and I would end up with 2 over 392. So 2 over 392. So 7 plus 2 is 9 over 392 is exactly what I'm looking for. So I end up with 9 over 392 on each side of my equation. So I can go back up, and I can say that x equals 14 is a valid solution. Now, you always want to check your answer if you have time. One thing that would have saved you a little bit of time here, if you were on a test and you were kind of pressed for time, you can easily see that in each case, for the rational expressions, for this one, and this one, the only number that would violate the domain is an x value of 0, right? So if you were pressed for time, you could figure out what is the domain for each rational expression and find any value that violates that domain. You would exclude that as a possible solution, right? Those would be extraneous. So you can kind of do it that way if you're pressed for time. But the way I suggest is solve the equation and then go back and plug in the solution and make sure, first off, that you got the right answer, and second off, that it's not extraneous. All right, let's look at one that's a little bit more tedious. So we have 7x plus 4 over x squared plus 11x plus 28. And this is equal to, we have 4 over x plus 4 minus, we have x minus 8 over x plus 7. Okay, so the first thing I want to do is just find the LCD. So for these guys right here, this x plus 4 and this x plus 7, those denominators are not going to factor, right? But this guy right here, it looks like I can factor that. So what I'm going to do is I'm going to go ahead and write my x here and my x here. And if I think about two integers that sum to 11 and give me a product of 28, well, I know that's going to be 4 and 7, right? So I get x plus 4 and then x plus 7. So if I look at x plus 4 here and x plus 7 here, here I have x plus 4, here I have x plus 7. Well, this guy right here is going to be my LCD, okay? So what I'm going to do is I'm going to multiply both sides of the equation by that LCD. I'm going to be a little bit pressed for room, so I'm just going to do this individually, okay? So I'm going to multiply this by my 7x plus 4 over my, again, I'll do this in factored form, so x plus 4 times x plus 7. And we can clearly see that this would cancel with this, and I'd be left with my 7x plus 4. So I would just have my 7x plus 4. And then let's go ahead and do that for this part right here. So I'm going to multiply by, let me just kind of erase this, my 4 over x plus 4. So in this case, I would have the x plus 4 cancel with the x plus 4, and I would have 4 times the quantity x plus 7. So let's put equals, we'll have 4 times the quantity x plus 7. And then lastly, let me kind of erase this. I'll be multiplying by, you have your minus, and then this guy right here, this x minus 8 over x plus 7. So we would have that. This guy cancels with this guy, and I'm left with my x minus 8 times my x plus 4. Now, you have to be careful here. You have this subtraction here, which I've written here. To make sure that you don't make a sign mistake, put a bracket there, and then go ahead and write that. So you have x minus 8 times x plus 4. So x minus 8 inside of parentheses times x plus 4. Okay. And we'll go ahead and FOIL that out. And again, that minus sign out in front of the brackets is going to make sure that I get the correct sign. Okay. So let's go ahead and rewrite this. So we have 7x plus 4 is equal to, I'll go ahead and clean this up. 4 times x is 4x. And then plus 4 times 7 is 28. I'll leave my minus out in front of these brackets. Go ahead and FOIL this. So you'd get x squared. The outer would be 4x and the inner would be negative 8x. So if I combine those, I get negative 4x. And then for the last, negative 8 times 4 is minus 32. Again, because I have this minus out in front of these brackets, I've got to go in and change the sign of each term here. Okay, so let me go ahead and go to the next line. We'll say we have 7x plus 4 is equal to 4x plus 28. Again, each term in here is going to change. So minus x squared, then plus 4x, then plus 32. Okay, so now I know I have the correct sign everywhere. And then what I can do here, since I have a quadratic, I have an x squared term, I want to get everything on one side, all the variables and all the constants, everything on one side and 0 on the other. Okay, so let's just go ahead and move everything to the right side. So first and foremost, 4x plus 4x is going to be 8x. So let's erase this and just put 8x. We know that 28 plus 32 is 60. Let's just go ahead and put this as 60 here. And nothing to do with the negative x squared. On the left side, I can subtract 7x away from both sides. And I can subtract 4 away from both sides. So on the left, I'm going to have 0. Okay? So on the right, let me kind of scroll down and get some room going. I'm going to have my negative x squared. And then 8x minus 7x is just plus x. 60 minus 4 is plus 56. Now, if you've been watching these videos in order, you know that I like my variable on the left. It's no problem to just switch this around and say I have negative x squared plus x plus 56 is equal to 0. Okay, perfectly legal. Now, if you want to make this a little easier to read, you can divide both sides by negative 1 and have a leading coefficient that's positive. It's not necessary, but it's something you can do if you want. So if I divide both sides by negative 1, just to kind of clean this up a little bit, I would end up with x squared minus x minus 56 is equal to, we know 0 over anything other than 0 is 0. Okay? So this is what I'm working with. Let me get some more room going. I'm going to have my x squared minus x minus 56 equals 0. So you can solve this with factoring. You can solve it with the quadratic formula. Whatever method you want to use. I'm just going to solve it using factoring because it's a little bit easier. So I'm going to have an x here and an x here. And this, of course, equals 0. Give me two integers whose sum is negative 1. And we'll have a product of negative 56. Well, that's going to be negative 8 and positive 7. Okay? So now I can solve this using my zero product property. So I would say that x minus 8 is equal to 0. Or x plus 7 is equal to 0. Very easy to solve these equations. For this one, I would just add 8 to both sides. And I would get x is equal to 8. For this one, I would subtract 7 away from each side. And I would get x is equal to negative 7. So let's go ahead and copy these. All right, so we want to check x equals 8, and then also x equals negative 7. So let's start by checking x equals 8. So I'm going to plug in an 8 here, and here, and here, and here, and here, and here. Now, if you plug in an 8 here, what's going to happen? 8 minus 8 is 0, and over here, 8 plus 7 is 15. We know 0 over 15 is 0. So I can go ahead and mark this guy out. I only have to deal with these two, okay? So in the numerator here on the left, 7 times 8 is 56. 56 plus 4 is 60. This is over. You have 8 squared, which is 64, plus 11 times 8, which is 88, plus 28. If I add all those amounts together, I'd get 180. We know that 60 over 180 is 1/3. Okay, so the left side here is 1/3. This guy right here, I'd have 4 over 8 plus 4, which is 12, We know that 4/12 is also 1/3. So we can go ahead and say that this solution, x equals 8, is a valid solution. Now, let's plug in x equals -7 and see what happens. So I'm plugging in a -7 here, 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 and here. Now, before I do anything, do you see a problem? Yes. Right here is where your problem is. If you plug in a -7 for x there, -7 plus 7 is 0. You can never divide by 0. It's undefined. So if you see that, again, one way to do this is to look at the domain of each rational expression first. If I look at the domain of this rational expression all the way on the right, I find that I have a problem, right? Because x can't be -7 in that case. So this guy right here has to be rejected. Okay, you can reject this and say it's an extraneous solution. So x equals 8 is the only valid solution here. All right, let's take a look at one more. So we have 1 over x cubed minus 11x squared plus 30x. And this is equal to, we have 1 over x squared minus 6x, and then plus, we have x plus 1 over x squared minus 5x. So again, I want to find the LCD first. So that means I need to factor everything. So for this guy, I know I could pull out an x first, and then I would have x squared minus 11x plus 30 inside. And then I would have to factor this again because it further factors. So this would be x and this would be x. Give me two integers whose sum is -11 and whose product is +30. Well, you can go ahead and say this is -5 and -6, right? -5 plus -6 is -11. -5 times -6 is +30, okay? So let's erase this. We'll kind of drag this up. So this is that factored form. Then this guy right here is going to factor into x times the quantity x minus 6. And this guy right here is going to factor into x times the quantity x minus 5. So if we look at the denominators, we can see that this is going to be the LCD, right? X times the quantity x minus 5 times the quantity x minus 6. So what I want to do is multiply each side of the equation by that LCD. Again, because I don't have enough room to kind of set this up in that long of a format, I'm just going to do them individually. So I'm going to multiply this LCD by kind of each part here individually, and I'll write the answer below so we can kind of move forward. All right, so if I have 1 over x times the quantity x minus 5 times the quantity x minus 6, let me kind of make that a little better, and I multiply this by the LCD, x times the quantity x minus 5 times the quantity x minus 6. What's going to happen? This denominator will cancel with this, and I'll be left with just 1. So on the left side of the equation, I'll just have a 1. Now, let me erase this, and I'm going to multiply this guy by this right here now. So I would have equals, so you have 1 over your x times the quantity x minus 6. So this guy is going to cancel with this, and I'm left with just the x minus 5 times 1. So x minus 5. You could put that in parentheses, but you don't have to. You're just multiplying by 1, so it's not going to really change anything. Then you have a plus, so let me write plus here. And let me kind of get rid of this. So now we're going to multiply by x plus 1 over, you have x times the quantity x minus 5. So what we're going to do is cancel this with this, and I'll be left with x minus 6 times x plus 1. So make sure you wrap each of these in parentheses. So you have x plus 1, that's going to multiply x minus 6. Okay, so let's scroll down. We've cleared all the denominators. And so we have 1 is equal to, you've got your x minus 5 plus. Go ahead and FOIL this out. X times x is x squared. The outer would be -6x. The inner would be plus x. So if you combine those, that's going to be minus 5x. And then for the last, you have 1 times -6, which is minus 6. If you clean this up on the right side, x minus 5x is going to give me minus 4x. So I'll write 1 is equal to, I'm just going to put minus 4x here. And then I have -5 minus 6, which is -11, and then plus x squared. And I'll reorder this in a minute. I want to subtract 1 away from each side of the equation so that this side on the left is 0. So I'll have that 0 is equal to, I'll write x squared out in front, and then I'll write minus 4x, and then negative 11 minus 1 is minus 12. Okay, so recall that I can just flip this around if I want to. It's perfectly legal. I can say this is x squared minus 4x minus 12 is equal to 0. So again, I can solve this using factoring. I can use the quadratic formula, whatever you want to do. Since we haven't used it today, let's just go ahead and use the quadratic formula, get a little practice. So my A is a 1, my B is a negative 4, and my C is a negative 12. So for the quadratic formula, we kind of just write it over here. X is equal to the negative of B. B in this case is negative 4, so the negative of negative 4 is plus 4. And then plus or minus the square root of, you've got B squared. Negative 4 squared is 16, minus 4 times A is 1, times C is negative 12. So you basically have negative 4 times negative 12, which is going to be positive 48. So 16 plus 48 is 64. So this is 64. If I took the square root of 64, I would get 8. So this is an 8 right here. And this is over. We would have 2 times A is 1, so just over 2. Okay, so I'm going to get two solutions here. X is going to be equal to 4 plus 8, which is 12, over 2, which is 6. And then X is going to be equal to 4 minus 8, which is negative 4, over 2, which is negative 2. All right, so let's copy these solutions. All right, so let's check this. So if I plugged in a 6 here, 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 and here, what would happen? Well, I want you to recall that the factored form of this denominator is x times the quantity x minus 6. If you put a 6 in right there, you would have 6 minus 6, which is 0, and 0 times 6, which is still 0, right? You can just kind of do this real fast. Let's go ahead and say that I replace this with 6, and I replace this with 6. So 6 minus 6 is 0. 0 times 6 is 0. So this denominator here would be 0, right? You can't divide by 0, so this guy right here is going to be an extraneous solution. You have to reject that. Okay? So x equals 6 is not a valid solution. So let's check x equals negative 2. Okay, so I'm going to plug that in here, and also here, and also here, and also here, and then also here, and here, and here, one more time, and right there. Okay, so a lot of stuff to plug in. Let's kind of get started here. So in the denominator here, I have negative 2 cubed, which is negative 8. And then minus, you have 11 times negative 2 squared. Negative 2 squared is 4. So 11 times 4 is 44. So minus 44. And then you have 30 times negative 2, which is negative 60. So negative 8 minus 44 minus 60 is negative 112. Let me kind of move this out of the way. I'm just going to scooch this down a little bit. So I'm going to say that this side on the left is negative 1 over 112. Okay, let's erase this. All right, so if I look at the right-hand side now, I'm going to have 1 over. You've got negative 2 squared, which is 4. And then basically you have negative 6 times negative 2, which is positive 12. Or you could say plus 12. So 4 plus 12 is 16. Let's put this as 16 here. And then we have plus. I've got negative 2 plus 1, which is negative 1, over. You've got negative 2 squared, which is 4. And then you've got negative 5 times negative 2, which is going to be plus 10. So this is going to be 14 down here. Okay, so what's the LCD? Well, 14 is 7 times 2, and 16 is basically 2 to the 4th power. So it would be 16 times 7, which is 112. Okay, so that's my LCD. So I would need to multiply this guy right here by 7 over 7. So this would end up being 7 over 112. I would need to multiply this guy right here by 8 over 8. So this would end up being negative 8 over 112. So negative 8 over 112. If you sum 7 plus negative 8, you do get negative 1, and it's over the common denominator of 112. So you see that you get negative 1 over 112 on each side of the equation. So x equals -2 is a valid solution.